Hello everyone, this is Greg. How are you today? We're going to talk a little bit this morning about the first week of the course, correlation regression, and actually the first 2 weeks. So we're going to start out with the first week. We're going to talk a little bit about correlation, just to review, make sure you understand exactly how it works. Most of this material is in the content of the course. But this is just to help you get a little idea of what we're doing. So first of all, in the course, correlation regression and causal comparative, which is also called ex post facto research, are included in one course. Now, what is the reason for doing that? The reason for doing that is that these two types of research methods only allow us to see associations between variables. Alright, so they do not in any way help us come to any conclusions about cause and effect relationships. The only way you can show cause and effect is through what's called a true experiment, and there's a whole course devoted to experimental research. So we'll go into a little bit more about that. So we're going to spend a little bit of time this morning talking about correlation first. Okay. If you're going to use correlation in a dissertation, there's some requirements that have to be there. And let's just go over them here first. So as you can see, I have a little picture here, and I have some data. And on this axis, this is the hours a student spent studying for the calculus test. And on the y-axis, let's put a little y there, that is the score person got on the calculus test. Now, what we have here is a sample. So don't forget, when you're doing research, you are only pulling a sample of folks normally. You could be using the whole population, but primarily you'd be using a sample. So we have a sample of 5 people here. And we gathered our data and we found that a certain person studied 1 hour a day and they got 10 on the calculus test. Another person studied 2 hours a day, and they got 10 on the calculus test. Another person studied 3 hours a day, and they got 40 on the calculus test. Another person studied 4 hours a day, they got 20. 5 hours a day, and someone got 70. So there's your sample of bivariate data pairs. Now, I very accurately graphed them here, and the first thing to notice is it doesn't look like a very good correlation. Well, what's very good or not is quite subjective. So, first of all, let's actually compute the R, the correlation coefficient. Now, if you go to the Basserstats website, and I've already done that, you should be able to put these 5 pairs in, and you should get an R, a correlation coefficient of 806. And if you do not, you should ask for some help, because you're going to need to use the Basserstats website. And you can use that website in dissertations because it is a very good tool for calculating anything correlation or regression related. So we have an R of 0.806. Now, the question as to whether that's a strong correlation or not is rather subjective. Usually that would be considered a pretty good or a strong correlation. Well, first of all, let's remember that the R, a perfect correlation of 1, means that all the points form a linear relationship. They are on one line. But an R of -1 means that all the points form a linear relationship that is downward sloping. Here's one of the things that's commonly misunderstood. The R has nothing to do with the slope of the line. It has nothing to do with the slope of the line. It's only a measurement of how close the points are to some linear relationship. So we could have R's of 0.806 with many different lines that they could form. Lines of best fit that they could form. All right, in this case, we have an R of 0.806. Okay, so you've gathered this data and you've reported this in your dissertation. Now, what's the next thing that has to be done? You have to determine whether this correlation is statistically significant or not. So if you go to the website, you go a little farther down, you will see a two-tailed p-value of 0.0994. And what does that mean? That means that the p of 0.0994 is not less than our standard alpha of 0.05. As a result, the null hypothesis in correlation is always that there is no correlation in the universe of bivariate pairs, or the whole population of bivariate pairs. Remember, you only have a sample of 5 here. So, since the p is not less than the alpha, we cannot reject that null hypothesis. So, we can't say that there is a non-zero correlation in the population. We can't reject our null hypothesis. The sample is too small. Now, if we had a larger sample and its correlation was 0.806 and we had a sample of 7, then the sample size would be large enough. I've calculated it, and we would get a p-value that would drop below 0.05. So then we would have a significant correlation. And we could say that in the population there's not a zero correlation, but a non-zero correlation, meaning in the population there is a correlation of some sort. But that would require a bigger sample size. Or we could maintain the 5 data pairs, and we could have an R, which is closer to 1. That would also reduce our p-value and make our sample correlation statistically significant. So that's the first thing to keep in mind, is you've got to test your sample for statistical significance to see if you can reject the null hypothesis that there's no correlation in the population in favor of the alternative, which there is. All right, so that's part 1. Part 2 is going to deal with multiple regression. So go to the calculator, check all these numbers, review the video, and match it with your content, and maybe that should help.